there is a high probability if you did not attend yesterday's class, which means if you don't have any idea at all what these things are, this is what we covered yesterday, then today's class is going to be a little difficult. If you do have an idea of what these are, then today's class should be fine. We'll take it slow. We'll first revise all the concepts here. We'll try to understand them with some examples, and then we will move on to deployments, replica sets, and services. And we'll, by the end, try to deploy our application on the internet if we get the time. If not, that is fine. The goal is to take it slow. Yesterday's class was a little fast, primarily because this is a new concept, I'm assuming, for most people. So we'll try to revise everything, specifically these 5 things, and then we'll go over here. All the slides are present on projects.100xdevs.com. If you sort this by newest first, you will find Kubernetes part 1 over here. You can also search for Kubernetes part 1. The things that we discussed yesterday were slide 1 to slide 10. What we're covering today is slide 11 onwards. But before we get here, I will quickly recap everything from slide 1 to slide 10. It is 7:04, so I think we can get right into it. Let's recap everything we did yesterday. Let's understand about clusters, nodes, images, containers, and pods. Let's kick things off with the simplest things we already know over here. We know what images are. See, Daisy, the whole thing got colored. We know what images. We know what images are. If you go to hub.docker.com/_/Mongo, this page that you reach here shows you a bunch of MongoDB images that were pushed. For example, there is this version of a MongoDB image that was pushed. If you want to pull this to your machine, you can run this command, docker pull mongo : the version that you're trying to pull. If you want to run it locally, you can run docker run mongo : something. Images and containers have nothing to do with Kubernetes. Even Docker has the concept of images and containers. The same thing we're talking about here. Now, Docker isn't the only container runtime. There are other runtimes that let you create containers. Containers is a more generic concept, but primarily us throughout the cohort and most people out in the world as well use Docker as their container runtime. If you do use Docker as your container runtime, you will be pushing your images here. Now you could create images of your own. If you remember back from the Docker classes, if I was signed in here, I would show you. Okay. See. Okay, during our Docker classes, we pushed our own images to Docker Hub as well. As you can see, 100xdevs/week18 class is an image that we had pushed. So a lot of smart people have created images on Docker Hub. You can push your own images as well. And usually what happens in companies is, okay, if this is the GitHub of the company, then anytime a commit happens on the master branch, a new image is created and that new image is pushed onto Docker Hub. And eventually this image is pulled by wherever you are running your application. You could be running it in a simple EC2 machine. You could be running it in an auto scaling group inside AWS, or you could be running it in a Kubernetes cluster. So the first part of what we learned yesterday, which was anytime a commit happens, an image is what is pushed to Docker Hub. That image is eventually pulled down to an EC2 machine, auto scaling group, wherever. And that image in execution, whenever on this EC2 machine docker run harkirat_backend happens, or what was our image name? 100xdevs/week18 class. Whenever on this machine docker run 100xdevs/week18 class happens, then this thing that is finally running is an image, is a container. So what are the two things we wanted to learn? Images and containers. These are things we have learned about in the past as well, nothing related to Kubernetes. If I quickly want to show you, if I run docker ps, it shows me a bunch of containers that I am already running. These things that are running are containers. If I run docker run 100xdevs/week18 class, which is this image right here that I had pushed to Docker Hub a few weeks ago, then I can, as you can see, it says unable to find image, this thing locally. It starts to pull it from Docker Hub And once it is able to pull it, it will run it here as well. That image running locally on my machine is what's called a container. Let's wait for it to run unless it takes a really long time. It is taking a really long time. Whenever this runs, I will have a container running on my machine. If I run docker ps, I will see a fourth container running on my machine. That is what are images and containers, non-Kubernetes concepts. Now, you are like, "Ki yaar, theek hai. I have in the past deployed my images to Docker Hub and pulled them to EC2. I have pulled them to an auto scaling group, let's say, but I have never pulled them to a Kubernetes cluster." So now you want to get fancy. Your backend team has a requirement that no, we will deploy on Kubernetes. We will not be deploying on simple constructs like these. Then what all do you need to learn? What are the very basic terminologies / jargon you need to know if you want to push your images over to a Kubernetes cluster and start containers over here? The three jargon that you need to know before you proceed at all is clusters, nodes, and pods. These are the three things we discussed yesterday. The other jargon you need to know is services. Deployments and replica sets are something extra. You can have a fully functioning running application on the internet with just clusters, nodes, pods, and services. These two things are slightly extra. Let's kick things off by understanding the first three things that we discussed yesterday: clusters, clusters, nodes, and pods. Whenever you go to a cloud provider, let's say I go to vultr.com over here. Today, in most cloud providers, you will see Kubernetes as a separate section. For example, as you can see, there is compute over here. What does compute mean? It means I want to start a simple EC2 machine or simple whatever machine you might want to call here. If I click on deploy, it will take me to a page where I can select the specifications of my machine. What kind of machine do you want? Which data center do you want to start it in? Let's say Mumbai. What operating system you want over there? How big of a machine do you want? Do you want a 1 vCPU, 4 GB RAM machine which has this much storage at $30 a month? Or you want a bigger one? You can select your machine. Click on deploy now. It will start a machine for you. Very similar to how we start EC2 machines. But when you go to the Kubernetes section, you will notice it says add a cluster. It does not say add a node. Whenever you are creating a Kubernetes deployment or a Kubernetes machine, let's say, this thing that you saw over here, this is a Kubernetes cluster that you start on a cloud provider, which means the very first jargon that we have to learn about, cluster basically means a bunch of small machines or big machines, doesn't matter, but a bunch of machines that are all part of your Kubernetes cluster. If I go to vultr.com again, and if I try to add a new cluster, if I go to the Kubernetes section and click on add cluster, it asks me, what version of Kubernetes do you want to run? Because Kubernetes keeps on getting upgraded as time goes by. What region do you want to run it in? Let's say Mumbai. And then it asks, how many nodes do you need to start? Do you need 1 node? Do you need 10 nodes? What is the size of every node that you need? And hence, Kubernetes always runs in clusters. Kubernetes is never really a single machine. You can still say that we have a cluster with a single machine, but usually you want more than one machines running in a cluster. So this can be called as node 1, node 2, node 3, and node 4. So what are the two jargons we have learned now? A Kubernetes cluster that you create, which has multiple nodes inside this. What is a node? It's just a machine. It is just a EC2 machine, or in this case, a Vultr machine. In fact, if I click on deploy now, right now, it will create a Kubernetes cluster for me. I just did that before the class. As you can see, it says over here, I have a VKE, which probably stands for Vultr Kubernetes Engine cluster, which has 2 machines running if I go to compute, the two machines that you see over here, this one and this one, are actually two nodes of my Kubernetes cluster. I never created these two by clicking on the deploy button. No, I went to Kubernetes and I created a Kubernetes cluster. Under the hood, these two machines got created for me. Any questions related to nodes and clusters in Q&A before we proceed over to pods? Can't we start pods in a master node? You can start it in the master node. You shouldn't do it because your master node is doing 10 different things. You don't want to overwhelm it with user related pods. So usually you should have separate master and worker nodes. All right, no questions. So we will proceed. A bunch of nodes, create a cluster. And when you want to deploy an application there, I repeat, whenever you want to deploy your Node.js application, for example, you create what's called a pod. So a Kubernetes cluster has a bunch of nodes, and whenever you want to deploy your application there, you create what are called pods. Think of pods as containers only. When we had an EC2 machine, how did we deploy an application there? If we were deploying it via Docker, I would do a Docker run 100x devs / week 18 class, right? Something like this. This is how I would deploy something on an EC2 machine. Similarly, if I have a Kubernetes cluster, rather than starting a container, I run something like Kubernetes start 100x devs / week 18 class, which starts not a container, but a pod. What does it start? It starts a pod. Now, what is a pod, Harkirat? It's just a logical abstraction on top of containers. KR, when you are in Kubernetes, you don't start a container, you start a pod. Now inside the pod, there is a container only running. Inside the pod, you have a container running. But the jargon to use / the thing that you have started is a pod. The only special thing about a pod is that you can start multiple containers inside it. So whenever you're doing a Kubernetes start this thing, you can give it 2 containers to start. KR, inside this pod, I will start 100x dev / week 18 class. I will also start, let's say, the Mongo container. That way, a single pod that is running on my machine has my container as well as the Mongo container. This is what we discussed yesterday. Okay, how do you start not containers, but pods in a Kubernetes cluster? Now this is very abstract. In the real world, these pods run on one of these 4 machines. So whenever I run the command, okay, Kubernetes start 100x devs / week 18 class image, this command goes to what's called a master node. Whenever you create a Kubernetes cluster, it has 2 types of nodes. One of them is called the master node. The other kind is called the worker node. You could have multiple master nodes and multiple worker nodes. But usually, at least initially, you would want to have just one master node and a bunch of other worker nodes. What is the goal of the master node? Here, whenever Harkirat sends this command, right, it reaches the master node over here. And then through a bunch of processes, there are a bunch of processes running on this master node. There are a bunch of processes running on this worker node. Eventually, a pod gets created in one of these 4 worker nodes. If worker node ever crashes, this pod gets moved to a different worker node over here. If this one crashes, Kubernetes will itself move it around to a different node. That's the power of Kubernetes. Okay, the end developer only has to say, KR, start 1 pod, or let's say start 3 pods of this specific container, this specific image, and Kubernetes will automatically deploy 3 containers on 3 machines. They will keep on running. If a node ever goes down, then Kubernetes will move this pod to a different worker node. Do we have a brief idea about pods, containers, images, nodes, and clusters? Okay, good enough. Great, actually. Seems like that most people are here from yesterday. 93% is beautiful. So this was our checkpoint from yesterday. Now Let's get into slightly more complicated things. Yeah, pod is great. If you remember, how did we start a pod yesterday? Let's quickly revert our configuration from yesterday. We had a Kubernetes cluster running locally. Again, if you did not attend yesterday's class, you will not understand this, or this will be a little hard for you to do, because we installed something called kind yesterday. Kind stands for Kubernetes inside Docker. And here we started a Kubernetes cluster by running the following command. We go to the creating a Kubernetes cluster section, or we can do it locally as well. We created a kind.yaml file. Oh, this one's a little more complicated. Wait, let's go to creating a Kubernetes cluster, and let's quickly create one for ourselves. You can create one on Vultr if you want on the internet, or you can create one locally. How did we create one locally? We used this library called kind, which stands for Kubernetes inside Docker. How do you create a cluster over here? You run this command, Kubernetes create cluster, and give it a name. This is the easy way to do it. This will start a single node. If you want to start multiple nodes, then you create a file like this, call it whatever, clusters.yaml, where we clearly say, okay, I want one master node, that's what control plane stands for, and two worker nodes. This will give me a Kubernetes cluster of 3 machines. Copy. Let me create a new file, clusters2.yaml. Paste it over here, and then run the command kind create cluster --config clusters2.yaml --name Sunday, because today is the Sunday class. If I run this command, what does it do? It starts a Kubernetes cluster locally for me. It starts a 3-node Kubernetes cluster. What are the 3 nodes? One of them is the master node. 2 of them are the worker nodes. We are just doing locally what I could have done on the cloud if I went to Vultr and then clicked on Kubernetes and then created a new cluster and selected 3 nodes. I can do this on the internet by going to Vultr and selecting a region and then selecting 3 numbers of nodes and clicking on deploy. This would create 3 machines for me on the internet. But since we are testing it locally, I'm running this command, kind create cluster --config, giving it a YAML file, giving it a name to start the same thing locally. Now, if I do docker ps, you will see I have 6 containers running. Because I have 2 containers, one that I started before the class and one that I started after the class, 2 clusters. If I do kind delete cluster --name local, which I think is my original one, and then I do docker ps kind clusters get clusters. I have 2 clusters running, Sunday that I just started and another cluster that I started before the class. Let me get rid of this local 2 cluster, kind delete cluster --name local 2. Now I have a single cluster running. Hopefully you do as well if you've run the same commands as me. And if I do a docker ps, I see 3 containers that are running that are simulating a Kubernetes cluster, that are simulating a setup that looks like this: 1 master node and 2 worker nodes. How can I check what all nodes are running? If you remember, the other thing that we learned about yesterday was kubectl or kubectl. Using this, you can run a bunch of commands. For example, kubectl get nodes will give me the 3 nodes that I'm running, or like the 3 nodes that are running my Kubernetes cluster, a master node and 2 worker nodes. This is how you start a Kubernetes cluster locally. You can start it on the internet as well if you go to Vultr. Yesterday's class covers this in a lot of detail. Now the question is, how do you start a pod over here? And the answer is you do kubectl create, give your pod a name, let's say Nginx. Give your pod an image. Let's say I'm trying to run the Nginx image. If you go over to Docker Hub or hub.docker.com/_/Nginx, you will see a popularly available image which starts a small HTTP server on port 80. We can use this. We can use our own image as well. Doesn't matter. I can totally replace this with 100x devs, sorry, dash dash image equal to 100x devs slash week 18 class, or I can start, you know, this nginx image, or I can start the Mongo image, doesn't matter, whatever image you want to start. And then lastly, the port that you want open on this specific pod. This is how you start a pod on an Kubernetes cluster. This is me sending this command. Okay, Kubernetes start this specific image. I haven't given it a number 3 yet. Okay, you should start 3 pods. I'm just telling it, please start 1 pod. This is the command that I'm running. What would this command do? This command would hit the API server on the master node, which would eventually, through a bunch of processes, deploy the final pod on a worker node. How does this happen under the hood is covered on slide number 2 if you want to go through it, but maybe don't go through it just yet if this is a little too overwhelming already. Let's try to create a pod. The command is incorrect because image spelling looks right. It's kubectl run and not kubectl create. So the command to run is kubectl run, give it a name, give it an image tuple and the port that needs to be exposed. If you run this command, we have started our very first pod in our Kubernetes cluster. Our 3 worker or like 3 node cluster now has a single pod running, which is running this nginx image right here. Do we understand this much? Okay, this specific command started a pod in our Kubernetes cluster. If we understand this, then we will proceed to doing the other things and, you know, playing with this a little bit. Okay, we do understand this. Great. Okay, easy enough. Cool. How can we confirm that we have a pod running? You can run kubectl get pods and it will give you, you have 1 nginx pod running. Now, the problem is, if you have 1 pod running and it crashes for whatever reason, let's say there was some crash that caused it to go down, how can you restart it? What if I want to start 3 nginx pods and not 1? What if I want my application to be highly resilient and I want agar worker node 1 goes down, then there is another worker node 2 that is taking care while this specific node is being repaired. Or let's say I ever deploy a new version of my application. I ever do Kubernetes start the same image but with a new latest tag, let's say. How can I first start new set of containers? First I will start this new container. If it is running, will I stop the older version of my application? If you've heard of red, green deployments, blue, red deployments, basically starting your first set of containers with your new code, and if it is working, only then stopping your old containers and then, you know, creating more copies of it. What if you want to do this? What if you want something else to manage pods? I repeat, what if you want, I want 3 pods of the nginx image to be created, but I don't want to manage them. If they ever go down, please bring them back up. If they ever get deleted, please bring them back up. If I ever tell you, here is a new version, nginx 2 that you have to deploy, then please first deploy nginx 2, make sure it is working, and only then get rid of nginx 1. This is where a deployment comes into the picture. So what is the new thing that we're learning today? After all the jargon we learned yesterday, the very first thing we're learning about is deployments. Let's go to slide number 11. A deployment in Kubernetes is a higher level abstraction. You will see this word a lot. A pod is a higher level abstraction that lets you create containers. And similarly, a deployment is a higher level abstraction that manages a set of pods and provides a declarative updates to them. It offers features like scaling, rolling updates, rollback capabilities. We'll understand all 3 of these very soon. But to quickly understand what it gives you, number 1, scaling. You just have to create a deployment and tell it, increase the number of servers to 10. It will automatically create 10 pods. How would I create 10 pods right now? I would have to run this command 10 times. KR kubectl run, okay, run another pod nginx2, and then run another pod nginx3, then run another pod nginx4. I would have to run 4 commands. I would have to figure out what name should I give them. I cannot repeat names. So, you know, it is a tedious process for me to start multiple pods. I now have 4 pods that are running, but it was very hard for me to run these commands 4 times. What if I could create a single thing? Here, Kubernetes create deployment -- image equal to nginx and -- replicas equal to 4. What if I could write something like this and it would automatically create 4 pods for me? Right now, if I delete one of these pods, let's say for whatever reason one of these pods get deleted, Kubernetes delete pod, it does not restart. However, if I create a deployment and give it here, you need to have 4 replicas. If a pod gets deleted, the deployment will recreate a fresh replica. That is why a deployment is very powerful and something you always use whenever you're deploying an application. The name itself says deployment. It takes care of starting pods. It takes care of rolling them back in case there is an issue in an update. It takes care of updating pods. It takes care of, if they go down, bringing them back up. What did it say here? It offers features like scaling. I can simply say कि यार अच्छा replicas equal to 4 नहीं, replicas equal to 10, and it will start 6 more containers for me. Then I say replicas equal to 3, it will stop 7 containers for me. Rolling updates. Whenever I tell it कि यार sorry, the image that you need to run is not nginx but nginx2, it will first start nginx2 containers. If they are working correctly, then it will stop the old pods that are running nginx. That is what rolling update means. And rollback capabilities. If this was the first command that I ran, let's say here start a deployment on nginx with 4 replicas. If I ran this command, let's say it started 4 pods for me. Somehow it did that. Then I said no, sorry, start the same deployment but with a different image, nginx2. And let's say nginx2 doesn't exist. Then our pods will begin to fail. A deployment lets us roll back to our existing deployment in a single command. So those are the benefits of a deployment. Let's see it in action to understand it a little bit better. Let's see how you create a deployment and how that deployment under the hood creates various pods. If you want to get into the depths of this, your master node, your control plane has this thing called the deployment controller, which is handled by the kube controller manager, which is something we discussed in slide number 2. That, you know, takes care of constantly checking, is there a new deployment and do I need to create new pods, or more specifically new replica sets? But we'll get there very soon. We'll get there when we get there. There is a difference between a pod and a deployment. This will always confuse you. This is a popular, interview question as well. What is a pod and how is it different from a deployment? A pod is the smallest unit in the Kubernetes object. It is something that you start that is running your containers inside it. A deployment manages pods. A deployment lets you create various pods and delete various pods. Harkirat, why can I not create and delete pods myself? Why can I not do this? Why can't I keep creating more and more pods? It's just tedious for you to keep creating them. You can simply create a deployment, tell it here, please start 4 pods. It will start 4 pods for you. Let's see this in action. A bunch of things here, which, let's go through them later on. We need to understand replica set before we understand deployments. But let's first create a deployment and then we can get into replica sets later on. Creating a deployment. Let's go directly to slide number 15. There is another concept we need to learn called replica sets, but we will get there after we finish deployments. A deployment technically creates a replica set. A replica set is what manages your pods, but let's ignore this for now. Let's purely focus on deployments. This is the manifest for creating a deployment. You can run a single command as well. I'm sure it's here somewhere. If not, you can run a single command as well that will start a deployment. but usually it's a good idea to create a manifest file very similar to the manifest we created for the pod. Let's see what this manifest file says. Let me create a new file here called deployment class.yaml, inside which I will paste the blueprint of my deployment. What does it say? KR from apps/v1 API version. Deployments were released a little later on in apps/v1 version. This version basically lets you separate KR pods are part of the Kubernetes v1 API and deployments are part of the apps/v1 API. In the future, there might be apps/v2 APIs, v3 APIs based on what kind of thing that you're trying to deploy. What are we deploying right now? A deployment. Where does a deployment belong? In the apps/v1 API. Kind is deployment. Let's compare this to our pod manifest. If you remember, yesterday we went through the pod manifest as well. KR, this is what the manifest file for a pod looks like. API version is v1. For us, API version for a deployment, it's apps/v1. Kind was pod. The kind here is deployment. The name that we gave to this pod was Nginx. The name that we're giving to this specific deployment is Nginx deployment. The spec here contained the details of your container. The specification was what all containers do you want to start? The specification here, of course, is a little different. What all do you need when you're starting a deployment? You need how many pods should I start? How many replicas do I need for a specific pod? This part is important and directly related to this part right here. I repeat, the selector match labels app Nginx is directly related to template metadata labels app Nginx. Whenever you are creating a deployment, you are saying start 3 pods. You need to tell it कि यार ये जो pods आप create कर रहे हो ना, the pods that you're creating, make sure they have some label attached to them. For example, app equal to Nginx. This could be anything. The label could be anything. कि team equal to backend. कि this is specific thing is probably not the best label. App equal to backend.100xdevs.com. Okay, this is the specific thing that we're trying to deploy. The label that you see over here, the match labels that you see over here, is how the deployment knows कि यार मेरे pod कौन से हैं, what pods belong to me. Whenever this guy starts 3 pods eventually, it needs to know कि यार these 3 pods belong to my deployment. If one of them crashes, it needs to restart a pod with a similar label attached. This label that you see over here, ignore this selector for now. You are creating 3 replicas, and this is the template for each and every replica. Every replica that is starting, every pod that is starting needs to have one Nginx container, and every pod that is starting has app set to Nginx as a label. Every pod that is starting, this spec that you see over here is the same as this spec that we saw in the pod. Exactly the same. We are telling the deployment here you need to start this specific type of pod. But one extra thing we are telling it is that these pods will have a label called app set to Nginx. And why are we doing this? Because we're also telling the deployment that whenever you find the containers, right? Whenever you want to know are 3 containers up or not, you will find 3 containers that have this specific label attached to them. So this is us telling it कि यार जब तू pod start करेगा ना, when you will start the pod, attach these labels to it. This is us telling the deployment कि यार when you're trying to find the pods, right, the 3 pods that belong to you, this is the labels that you should be looking at. If I manually start a 4th container and give it this label, कि यार you are also app Nginx, the deployment will delete it. The deployment will be like, यार I only need 3. This is my selector. This is how I know that some pod that is running belongs to me. This is how I know that I need to make sure that सिर्फ only 3 pods exist. So even if I manually create a pod with these labels, app : nginx, the deployment will either stop this or it will stop a different one. It will make sure that only 3 pods exist. That is where this part and this part comes into the picture. Everything else is fairly simple. You're starting a deployment, you are giving it a name, you are starting 3 replicas of it or 3 copies of it. And this is the spec of your pod. This is how your pod should eventually look like. These are the containers it should be running. This part is number 1, telling what labels to attach to the pods. And this one is telling how to find the pods that you are supposed to manage. If the number of pods that have app nginx go down to 2, it is the responsibility not of the deployment, it's actually the responsibility of the replica set. But for now, let's assume it is the responsibility of the deployment to bring them back up. Do we understand a little bit this file, this deployment file? Do we understand? We will apply this very soon and see how 3 containers start or 3 pods start. But do we understand deployment? Sort of, we don't. 70%, that is fine. We will take a breather. Let me maybe start it really quickly and then I will ask again. Okay? I wrote this really long file. Let me keep this open over here on the left. This is the deployment that I'm trying to create. Let me also clean up my pods. Kubernetes get pods, delete pod nginx, delete pod nginx -1. Let me get rid of all of the pods that I'm running. I have no pods running now. Now, let me apply this deployment. Notice I'm not applying a pod manifest. I'm not applying this pod manifest. I am just applying a deployment manifest. I am creating a deployment. How do you apply a specific YAML file? kubectl apply -f and the name of the file, which in my case was, I haven't saved this, deployment -class.yaml. I run this single command, kr start a deployment. I do not say start pods. I say start a deployment. And it says deployment has been created. What did I start? I started a deployment. Did I start a pod? No, I did not. If I go to kubectl get deployment, it tells me, Harkirat, you have 1 deployment running, 3 on 3. What does this 3 on 3 mean? Let me try to get all the pods. And notice there are 3 pods running automatically, even though I only created a deployment. The deployment clearly knows, okay, I need to create pods like these. And it created 3 pods for me. The deployment, again, technically did not create 3 pods. Deployment created a replica set created 3 pods, but we'll be getting to replica sets very soon. If I delete one of these pods, I deleted the 3rd pod. If I try to get pods again I have 3 pods. The deployment is making sure कि यार 3 तो रहनी चाहिए. 3 should always be there. Even if you delete a pod, the deployment will make sure it restarts it. So what is a deployment again? You create a deployment. Deployment under the hood creates bunch of pods. And even if you delete a pod, the deployment will bring it back up. It knows that I need to keep 3 replicas up all the time. If you describe this specific pod, you will see it has labels attached to it, which is app equal to nginx. This is how the deployment knows that these 3 pods belong to me. And that is exactly why if you delete one of them, it brings it back up. Do we understand deployment a little bit now? Okay, how creating a file like this ends up creating not just a deployment, but also 3 pods under the hood. Okay, we understand it now. Great. So one technical thing that is incorrect here that we should fix ourselves on is a deployment doesn't actually create 3 pods. A deployment creates a replica set, and a replica set is what creates 3 pods. I hid this thing in the middle from you. Harkirat, if a deployment creates a replica set and replica set creates 3 pods, why do you need a deployment? Why can't I simply create a replica set? Great question. We will get to that very soon. But first, do we have a deployment running right now? Yes, Harkirat, we do. Do we have a replica set running right now? kubectl get replica set. Yes, we do. One replica set was automatically created. What is a replica set? We will come to very soon. But a deployment creates a replica set. This replica set, as you can see, desired 3, current 3. This is the thing that makes sure your number of pods are finally 3. Deployment creates a replica set creates pods. Good question to ask is, why can't I simply create a replica set? It will create 3 pods for me. Why do I need this deployment? We will come to that very soon. First, let's only create a replica set and see if it does create 3 pods. Let's delete the deployment. Another amazing thing you will see here is, if I delete the deployment will delete the replica set it created. When the replica set is deleted, it will delete all the pods that are created. So it makes your life much easier if you use these higher level constructs. You don't have to create 10 pods. You don't have to delete 10 pods. You simply delete the deployment and then everything will get deleted. If I now try to get pods, it says no pods exist. So in a single command, you can start 3 pods. In a single command, you can get rid of 3 pods. Let's understand replica sets really quickly, and then we'll understand the difference between deployments and replica sets. And then, that's a good checkpoint for us to take a breather at. Creating a replica set. Now, as I said, until now, we had created a deployment which created a replica set, which created 3 pods. What is a replica set? As the name suggests, a replica set in Kubernetes is again a controller. It again exists over here in the kube control manager that ensures a specific number of pod replicas are running at any given time. This is exactly what we wanted. We want KR, please make sure 3 replicas are running at all times. We use a deployment for it, but seems like replica set gives us the same thing. It is used to maintain a stable set of replica pods running in the cluster, even if some pods are deleted or failed. You get the idea. Even if a pod is deleted, it will restart it. How do you create a replica set? Let's look at the configuration. It will look very similar to the configuration we created for the deployment. Let me create a replica set class.yaml file and paste this over here. What does it say? Here I'm trying to create a replica set. This is the name of the replica set. I need 3 replicas created finally. This is my selector. This is my template. This is how you identify the pods. Exactly the same as a deployment. Nothing new here, so I'm assuming this is fairly straightforward to understand. Exactly the same, only we change the kind to be replica set from being a deployment. Let me apply this. kubectl apply replica set class.yaml with a -f. It says replica set has been created. If I do a kubectl get rs, it gives me, Harkirat, you have created an nginx replica set. This name comes from here. And if I do a kubectl get pods, again 3 pods have been started. If I delete one of them, again it gets restarted. Even if I delete a pod, it gets restarted because the replica set makes sure that the number of pods at any time is equal to 3. Do we understand replica sets? Seems like exactly the same thing as a deployment. No real difference here. There is a difference. We'll be coming to that difference very soon. But are replica sets straightforward? I'm assuming if deployment is straightforward, then replica set is straightforward. Exactly the same thing. Great. Now the question is, okay, Harkirat, why do you even need a deployment? What extra does a deployment provide you? If all that deployment does is creates a replica set, then why can't we just use a replica set? Let's do an experiment. Let's update the image to be nginx2 in a deployment. So number one, let me get rid of the replica set that I had created, which will in turn get rid of all the pods that are running. I have a clean slate now. I have no pods running. I have no replica sets running. I have no deployments running. Let me apply the first deployment again. kubectl apply -f deployment -class.yaml. Okay. It created a deployment. kubectl get deployment. I have one deployment running. kubectl get rs. I have one replica set. kubectl get pods. I have 3 pods running. Life is good. Now I want to upgrade my application. I want my image that I want to run is no longer nginx :latest. It is some new random image, let's say nginx2. Assume it exists. It doesn't. There is no image called nginx2 on Docker Hub, but let's say there is. If I do this, I change the image to be this, and then I reapply my deployment. What would have happened now? Harkirat, you had an old deployment which had started a replica set which started 3 pods, pod 1, pod 2 and pod 3. Now you have updated this deployment. So that will either update the replica set, Harkirat, or it will create a new replica set. And then it will start 3 more containers with the new image. What do you think would have happened? What do you think should happen? Should I, whenever the deployment is updated, should I just update the existing replica set, which will just update the existing pods? Or should I create a new replica set, which should create new set of pods? What do you think happens? Take a second to think about it from first principles. Here we had an old deployment. Then let's say our master had some new commits. Then we are making a new deployment. We are giving it a new image. Should I just update replica set over here and update my existing pods? Or should I just update replica set here, delete my existing pods, add 3 more pods? Or should I create a new replica set? Let's do a poll to understand what do you think from first principles. Do you think, I'm giving 2 options, happens choice 1 or choice 2. Choice 1 is that it just updates the old replica set, and choice 2 that it creates a new replica set where it deploys 3 more pods. So 40% think it's choice 1, which is the wrong choice, and 60% think it's the choice 2, which is the right choice. What did deployment give you? If you go back a few slides, what was the definition of deployment? It gives you features like rolling updates. What does a rolling update mean? I will first create more pods. I will make sure they are healthy. If they are healthy, I will slowly start to move your traffic here and get rid of the old pods. That is what a deployment provides you. A deployment creates a fresh replica set. If everything is fine, it will scale down the old replica set, scale up the new replica set. But if something is wrong here, it will make sure the original replica set is also there and the original set of pods are also there. If I go back here and do kubectl get pods, you will see I have 4 pods running. 3 old ones and 1 new pod. It's tried to start 1 new pod. It said here, I will start a replica set with just 1 replica and see, does it actually start? If this actually starts is when I will scale down the first pod here. Then I will increase this to be 2 replica sets. Then I will scale down this, so on and so forth. It creates a fresh replica set for us. If I do kubectl get rs, you will see I have 2 replica sets, 1 old one running and 1 new one with the desired capacity of 1 only right now. I am rolling an update. I'm trying to see कि यार ये जो नया वाला है, as you can see it's now in error image pool. image is not being pulled. It tried a few times. The nginx2 image doesn't exist. If I go to deployment.yaml, dash class.yaml, this nginx2 is no valid image, and hence, it tried a few times, did not happen, and then eventually it still has the old replica set, still has the new replica set, but it has maintained the whole set of pods. If any request comes to this container, it will send it to these good pods and not the bad pod. If I change deployment.yaml to be a better image again, for example, let's say Postgres, and then reapply the deployment, it will again start. First, a new pod container is creating. Now this time the image is correct. Postgres is an image that exists. So it's trying to create the container. Eventually this will fail as well. Whenever you're starting the Postgres container, you need to give it some environment variables, else it fails. So even this will fail. And here also you will see, the existing 3 keep on running. So do we understand why you need a deployment? If you only use a replica set, then anytime you're making a new deployment, if you want rolling updates, you will have to create a new replica set. You will have to monitor कि अच्छा health सही है कि नहीं, is the health correct or not. If it is not correct, you will have to delete the replica set. Versus if you have a deployment, it takes care of this for you. It says, whenever you give me something new, I will create a fresh replica set. If the final pods here are good, if the health check succeeds, then I will scale down this original replica set to be 0. So that is why you need a deployment over a replica set. Do we understand deployments and replica sets and pods? What all did we have to learn today? We had to learn deployments, replica sets, and services. We'll get to services very soon. But are we good to go? Can we take a small break? Maybe it's 7:55 and then proceed. All right, probably don't even need a break. 93% is great. So if we understand this as well, again, let's go back to the pods and see what's happening. It says crash loop backing off, which means we're trying to run it. It's not an image pull error anymore. It is an application level error. Your node index.js is failing, or in this case, logs. If I see the logs of it, it says you must specify Postgres_password to be a non-empty value for this to run. Basically, in my deployment class.yaml, I will have to give a environment variable here as well, which I totally forgot how to give. Should be in the slides somewhere. Let's see. That is how you give an environment variable. The environment variable being Postgres password. Whenever you want to start Postgres in a Docker container or otherwise, you need to give the Postgres password, else it will fail. Now that I've added this environment variable, basically even if I do Docker run Postgres, it will not work for me. It will say database is uninitialized, you need to give it a password. You need to pass in, this environment variable, Postgres_password equal to password. Only then does the Postgres container start. Even if you want to start it using just a Docker, not just Kubernetes. I have now passed in that environment variable. Now if I do a kubectl apply, it says configured. If I do kubectl get pods, this time this will work. This Postgres container will start, and then eventually these 3 pods will be scaled down. The pods are not scaled down. Again, the replica set is, as you can see, now this went down to 2 and this went up to 2. Slowly it is ramping up this one, ramping down the old one. If I do kubectl get pods now, we have 1 container creating and 3. This one is a Postgres container. As you can see, it started 24 seconds ago. This is the next one that is starting, and one of the Nginx controllers pods have been scaled down. If I keep doing this again and again, you will see all 3 of them are now Postgres. This age is 40 seconds, 8 seconds, 36 seconds, which means they were recently started. And now we have actually rolled out an update. Slowly we rolled it out. First we started 2 containers of the new one. We had 2 containers of the old one running, and eventually now we have all 3 of them running. If I see the logs of this container, you will see it has, these are Nginx, sorry, these are Postgres logs and not Nginx logs. Are we good to go? Do we understand? I guess we do. Cool. Last thing that's left is selectors for today. Sorry, not selectors, services. How do you expose the application? Let's take a small break, maybe like 7 minutes. Let's restart at 8:05 and quickly get rid of services as well. I think the class today is fast enough, so should be straightforward what needs to be done from here. Small break of 7 minutes. We'll restart at 8:05. Let me open chat until then. All right, start. What is the benefit of running more containers in the same pod? I discussed this a little bit yesterday. The benefit of running more containers in the same pod is a lot of times you have applications that need to talk to each other directly, that need to share the file system. If this is your cluster, inside the cluster you have, let's say, a node. Inside the node you have a pod. And this pod, let's say, needs to have two backend processes that need to talk to each other. So you'll have two different containers. Maybe they talk to each other via Redis. So you can start an internal Redis for these guys so that they can talk to each other directly without having to expose Redis, outside the container. They can directly talk to each other in the same, container context rather than, starting them in different. You can totally start them in different pods. You can always be like, yeah, every pod of mine will have a single container only. That is fine. But let's say you want, yeah, this backend process 1 and backend process 2 only need to talk to each other. They never talk to the outside world. So it's a good idea for you to, or they need to share the file system at all. Okay, whatever file system they have, the one process will be writing to the file system, other will be reading from the file system. So if you start them in the same pod, they can share all of this. They can talk to each other much faster than, having them communicate across pods. Are the nodes always up in a cluster even if nothing is running on it? Yes. Kubernetes can start and kill nodes whenever needed. It can, so depends on your cloud provider. Basically depends on you. If I have 5 machines over here, I start Kubernetes on all 5 of them. It will keep on running forever. What you usually do is, okay, you have your Kubernetes cluster auto scaled. Whenever if I go to my Vultr dashboard here, or even if you go to your Amazon dashboard, wherever, you will see whenever you create a cluster, it gives you 2 options. Let me show you really quickly. If I go to Kubernetes, go to this cluster. This cluster, if I go to the nodes, it has 2 nodes currently. It has an option to resize pool. So basically it depends on me, the developer. I feel a lot of load is coming. I will increase the number of nodes to be, let's say, whatever, 100. But one thing you can do is auto scale. Okay, I want minimum 2 nodes, maximum 10 nodes based on the load. This becomes super useful. This is also like a lot of things you have to keep in mind as to how things auto scale and downscale. But if you do this, then of course, if you have no load, you will have 2 nodes. As you start more and more pods, and let's say your pods have a minimum requirement of 2 GB CPU, then as your pods keep on growing, then it will eventually realize that you need 32 GB of CPU or 32 GB of RAM. 2 nodes aren't enough to handle that. It will auto scale to 3 servers. If eventually all of your pods scale down, it will understand that you don't need 3 servers anymore. It will scale them down. So it depends on you. You can have them provisioned manually. This is fine as well. And in this case, it depends on you. Kubernetes will never take it down. You told it start 2 machines, it will start 2 machines. If you do use auto scaling, then here you can play with, your pods a bit to figure out / understand when you want to scale up and scale down. So that's a brief of, how auto scaling happens. Also, if you have 3 nodes, can I run 5 more than 3 pods? You can run 5 pods on 3 nodes. There is no real requirement of, one node can run only 1 pod, a single node. Just how I can start multiple Node.js processes on my machine. Similarly, you can have, hundreds of pods running on your single machine. You'll eventually run out of memory. If you start thousands of pods, you should auto scale if you have that many pods, and a single node isn't enough. But yeah, you can, if they're very lightweight pods, you can start 20 pods on the same node, doesn't matter. If you remember here, I can just, if I go to deployment class.yaml and increase the number of replicas to be 20 and apply it, then I will have 20 pods running on my 3 node machine. It's fine, doesn't matter, like it can handle it. Auto scaling groups versus Kubernetes, significantly different on what they are trying to achieve. An auto scaling group has a bunch of EC2 machines. Auto scaling isn't the power of Kubernetes. Kubernetes isn't trying to achieve auto scaling. It is trying to give the developers a way to easily orchestrate their containers. What is Kubernetes? Kubernetes, does it have auto scaling in the name? No. What is Kubernetes? It is a container orchestrator. What is auto scaling group? What is an ASG? The name itself says auto scaling group. It lets you auto scale your servers. Big difference. Kubernetes का just one small part is कि यार, do you want to auto scale? Do you want to change the size number of nodes that you have as time goes by? That's just one part of Kubernetes. The real power of Kubernetes is container orchestration. कि you created a deployment. You get the idea. You created a deployment which took care of creating a replica set, which took care of creating a bunch of pods. Orchestrating these pods on various machines, various nodes of a Kubernetes cluster is what Kubernetes does. That's their primary, what it gives you. What does an auto scaling group give you? Here I will start 20 machines for you, and you can deploy your node app, node index.js here also, and here also, and here also. That way you can handle much more load. You can put a load balancer in front of it. So significantly different in what they try to achieve. Which one is better? Depends on a lot of things. For example, if you have a microservice architecture, basically, if you have a microservice architecture, you have a bunch of small services that you run, then auto scaling group is not the best idea. Why? Because you might start an auto scaling group for your JavaScript process. You might start an auto scaling group for your Golang service. What is it? It's a microservice architecture. It means small, a lot of microservices you have. This is a Golang process, let's say. You created a separate Golang cluster for it, or a Golang auto scaling group for it. Now let's say you have a lot of load on your Golang cluster. You will have to scale this up. And then next day you have a lot of load here. Then you have to scale this up, scale this down. If you have a Kubernetes cluster, then you can be like, yaar, ye hai hamari hazaron machines. These are our thousands of machines. Whatever services we want to deploy, all of them will deploy here. There will be a Golang service might be running here. Node.js service might be running here. They are all sharing compute. If at any point in time the Golang processes get a spike, then these servers can handle that. And if this spike goes down, Node.js process gets a spike, the Node.js process can use those resources. So that is where Kubernetes ends up shining. But as you can see, it's very complicated as well. So you should pick and choose if you want to go with Kubernetes. Most companies don't, unless you need cloud native, basically. If you want to be able to switch easily from one to another, or if you want to eventually go to your own data center, then it's highly advisable that you use Kubernetes. Yeah, that's a brief. All right, 8 to 6 already. Cool, guys. Let's finish off the last thing, and then we'll open it up to questions. Seems like the class is going fairly fast today. How to expose the application is the last thing. KR, you have a bunch of pods, Harkirat. Now we have 20 pods running on my machine. Some of them are running, some of them are failing. I think I started too many. Let's go to deployment class.yaml. Replace this back to, let's say, just 2. Now I have 2 pods that are running. Question is, how do I visit them, Harkirat? You started. Let me also change the deployment image to be not Postgres, but Nginx. Let me reapply. You started an Nginx image, Harkirat. What did you do? You went to hub.docker.com/Nginx. You are starting this image inside a bunch of your pods. But this image does expose something on a specific port. If I run this image directly on my machine, docker run Nginx with a port mapping of, let's say, 3001 maps to the 80th port on Nginx on the container. If I go to localhost 3001, I see a page that looks like this. This Nginx container isn't Vakus. It's not doing something random that it doesn't want to expose to the world. It wants to expose a simple HTTP server that gives you a page like this. If I run it using Docker, I can see that page over here. Why can't I see the same page, or how can I see the same page if I'm running it using Kubernetes? As I said, Kubernetes has a cluster which has a bunch of nodes inside which you run a bunch of pods. These pods are not accessible to the outside world. If this specific node's IP is, 55.222.1.3, I can't simply do something like this and reach the specific pod. If you want to be able to discover a pod, if you want requests to reach a pod, you have to create another thing called as a service. A service is what exposes your pods over the internet. If you want to ever get a public IP for your service, point this to, whatever domain name of yours, harkirathwebsite.com, then you need to create a service in Kubernetes. How to expose the application? Yeah, so basically right now, if I do kubectl get pods -ovide, it tells me that this IP is where your Nginx container is running. What was my deployment that I deployed? I said run Nginx. So Nginx is running somewhere. It is also telling me that this is the IP where it is running. This is the IP of your pod. But if I try to go to this IP on port 80, where Nginx should have been running, I can't reach there because, even looking at it, you can tell this is a private IP. It starts with 10 dot something. It is a private IP. It can be used by these containers to talk to each other, by these pods to talk to each other. But the outside world cannot access these pods until you introduce a service. If I do try to go to this, whatever URL I got, it will give me a page like this. Okay, this site cannot be reached. This is not a public address that you can hit. This is a private IP address, a logical private IP address that Kubernetes has created for the pods. You cannot access this like this and, hope to reach your Nginx container. How do you reach your Nginx container? You create a service. In Kubernetes, a service is, again, what? It is an abstraction. What is a pod? It is an abstraction that lets you create a container. What is a deployment? An abstraction that lets you create replica sets. What is a replica set? Abstraction that lets you create pods. What is a service? An abstraction that defines a logical set of pods and a policy by which you can access them. What does it define? You might be having multiple pods. Whenever you start a service, you have to tell them, you can access this pod and you can go to this pod. These are the two pods that I want you to forward the traffic to. And how do you want this service to be discoverable? Do you want to create a load balancer? Do you want to expose just on the node, the IP of the node, or something else? So what do you have to tell it? That defines a logical set of pods, what all pods you need to hit, and a policy by which to access them. So you need to give a service two things: what all pods it can access, how it can access them. Service will provide a way to expose your application by running a set of pods as a networked service. Here are the key points. Ignore this. Let's create our very first service. We can eventually get into the architecture, how it does things under the hood. Let's create our very first service that will hopefully expose our application over our cluster. Amongst the many manifests that exist, let's introduce another manifest called service-class.yaml and paste this over here. What does it say? Our API version v1 may services were introduced. The thing that I'm trying to create is a service. The name of this thing is Nginx service. The selector, how does it know what pods to forward traffic to? And the answer is the pods that have apps set to Nginx in your labels. Just how the replica set identified the pods, the deployment identified the pods, the service is also identifying the pods. Jis app is set to Nginx. Those all pods belong to you. You can forward traffic over there. And lastly, ports. What all ports do you want exposed? The protocol that you want them exposed over, TCP. It's an HTTP server. We're hitting it over TCP. The port on which it should be exposed internally. The target port on which you should hit the container. And lastly, the node port as to where it should be exposed over the internet. I'll take you through all of these very soon. The first thing to focus on here is type node port. There are various types of services that you can create. If you have a Kubernetes cluster which has, let's say, 2 machines, and this machine is running, let's say, 2 pods, and this is running a third pod. Let's say both of these pods over here are the Nginx pods. You can create various types of services. One service is simply KR, I want only other internal services to load balance across both of these Nginx containers. I don't want to expose it over the internet. I just want some other service, rather than hitting the direct IP of this guy, rather than hitting, what was the direct IP of our Nginx container? It was 10.244. whatever. Rather than this guy hitting this container directly and then trying to hit this container directly, it can hit a service which will load balance the load across these two. That is one type of service. Services are of many types. As you can see, the one that I had created here was of type node port, but you can have cluster IP as well as load balancer. There are more types of services, but these are the three common ones. Cluster IP, as the name suggests, lets you expose your services, your pods over an IP inside the cluster. It will give you another IP over here, internal IP 1.2.3.4. If another service wants to hit these in a load balanced fashion, it can use this IP. That is what a cluster IP is. Something we are not focused on right now. What are we focused on? I have these two pods. How can I expose them over the internet? I want them, if I hit this specific node on a specific port, it should take me to both of these pods in a, let's say, load balanced fashion. We are focused on node port. What is a node port? The multiple nodes that you have, you can expose the same port on all of these nodes, and they will all route to the same set of containers that you have selected. That is what a node port is. How many nodes do I have running currently? If I do Docker PS, I have one master node and two worker nodes. A node port service would expose a single port on all three of these. I can hit any one of these nodes on that specific port, and it would forward the request over to these containers. That is what a node port is. That is the kind of service we're trying to create here. If I open it again, what did I write? I said, create a service of type node port on this specific node port. This can unfortunately write in a very weird range of 30,000 to some 30,200, something like that. So you have to choose a very weird name, like number here. This is why you don't use node ports in production. You use something else. But this is a great start to expose your application. What are we trying to do? We are creating a service which will open up the same port on all of my nodes, which will forward my request to this pod. How does it select the pod? The pods that have this label right here. If I apply this, let me open this on the left. And try to apply service-class.yaml. It says service has been created. If I do kubectl get services, it shows me you can visit it on 3007. Ideally, by this time, if I go to localhost 3007, I should have been able to, I am able to access this, surprisingly. Docker. A lot of you might not be able to as well. Services. I have this Nginx container service, which is running something on port 30007. Get delete service, Nginx service, refresh, it goes away. Apply service, refresh. Yeah. it shouldn't be running ideally. I don't know why it ran for me before, probably because of my old, I have no idea why it was running before. It shouldn't be running right now. And the reason for that is, okay, we are running the Kubernetes cluster locally. As you can see, even though I have created a node port, which means if I go to, any of my nodes, for example, Docker PS, I have these 3 nodes running. If I go to the IP of any of these 3 nodes, I should be able to find something running here. But the problem is, this is a little hard to explain. Since I'm running this locally, right? Basically, if I was running this on Vultr, it would have just worked like this. If I was running this on the internet, it would have just worked. I would have been able to go to, these are the 2 nodes that I have. Let's see. These are the 2 nodes that I have in my cluster. I would have just been able to go to this node's IP :30007, and it should have given me that specific page that we were looking for. If you want, I can show this very soon, and we'll see it does work on Vultr. The reason it doesn't work locally is because when you start these 3 machines, mini machines locally, there is something running on this Docker container 30007, but I haven't exposed it over my Mac. What is happening is, okay, since when you're running Kubernetes inside Docker, you have 3 Docker containers running, which are your workers. When I created the service, something is exposed on 30007 here, something is exposed on 30007 here, something is exposed on the same port here as well. But since these are Docker containers, unless I add a port mapping on my Mac machine, here are my Mac machines, whatever XYZ port points to the 30007 port over here, I won't be able to visit it. I cannot visit the container on this port because it's a Docker container. Doesn't matter what it's running. The same thing happens when you run Mongo, right? If you have a Docker container running that is running Mongo, unless you have a port mapping, here my machines, whatever 5432 port maps to this machine's 5432 port, I cannot visit it on localhost :5432. So even though my 3 containers are having a node port, they have a port exposed on the node, I cannot visit them until I add a port mapping over here. Until, if you look at these containers, there is one port mapping here. Okay, my machine's 49779 points to 6443 over here. I need to add more port mappings here. Okay, my machine's X port points to 30007 port over here. Do we understand this? या फिर ये गया ऊपर से? Again, this won't be a problem if you're deploying it on Vultr. ये एकदम ऊपर से गया से. Okay, we will take a breather. We will understand from the top what all has happened. ठीक है? Ignore everything, forget everything, fresh start. We have a local Kubernetes cluster using Kind. What am I running locally? Kind. Kubernetes inside Docker. What does it do? How does it create a cluster? It creates 3 Docker containers. One is the master Docker container and 2 worker Docker containers. It adds 1 port mapping on the master Docker container. If you look at when I run Docker PS, it says here your machine's 49799 points to 6443 on the master node. So if the master node is running something on 6443, I can visit it on my Mac on port 49779. If any request goes to localhost 49779, it gets routed over here. If I go to localhost 49779, if I go to it over HTTPS 49779, my bad, you will see it gives me back the Kubernetes API server response. The response is that you don't have access, but if I hit this specific port, it forwards the request over here. Now what did I do? I started a service. I said, yeah, I already have pods running. I have, let's say, 3 replicas of my pods. Pod 1, pod 2, pod 3. 3 replicas are running. I started a new service and called it what type? node port. I said, I want to start a new service. I want every node of mine to expose these 3 containers over a port. This node should also expose it over 30007. Same for this node and same for this node. I started this service and all 3 of my nodes are now exposing something on 3007. My master node was already exposing something on 6443. But was I able to visit it? Was I able to go to localhost colon 6443? No. This request reaches my MAC, does not reach my container, which is why we added a port mapping, or Kind automatically adds a port mapping. Here on this port, any request that comes goes over here. I need to do the same for 3007 port, and only then if I go to localhost colon whatever 3001, will I be able to reach the 30007 port over here, which is forwarding requests to this port, because I created this service right here. Do we now understand the extra step that I need to take? I need to add this port mapping, because even though all 3 of my containers are now listening on a port, I can't directly send a request here. I have to first create a port mapping, and only then will this request reach this port, which will of course forward it to my respective container. Do we now understand the extra thing I have to do, purely because I'm running it using Kind? If I'm running it on Vultr, if I'm running it on an open machine, then I wouldn't have to do something extra. But since right now I'm doing this extra step, okay, 82% is good. Let me finish this and then I will take more doubts at the end. I will also deploy it on Vultr and you'll see how quickly it gets deployed. Now I need to add a port mapping to all 3 of these containers. How do you do that? Thankfully, Kind gives you a way to do it. Whenever you're starting your containers using Kind, I wish it was here somewhere. Okay, I have it locally, but you might not be able to copy. If you are copying, I'm assuming most of you aren't. Cluster2.yaml. Whenever you're starting Kind, whenever you're starting a specific, or like giving it the configuration, KR, I need to start a master node, you can tell it, KR, add these port mappings. The container port 3007 or like 30007 should point to the host ports 30007. The container ports 30007 for the worker node should point to the host ports 30008. What is this configuration doing? This configuration is pretty much saying, KR, the master node पे जो 30007 चल रहा है ना, whatever 3007 is running there, the host nodes 30007 should point over there, and whatever is running on the first worker node on 30007, the host machines 30008 should point over here. You can also add it for the third worker as well if you want. KR, my machines 30009 port should point to this 30007 port of the third worker. You can update your Kind configuration to add these port mappings, extra port mappings that you need. This is the one that we need for the master node. This is the one that we're adding for the second node. We are not yet adding one for the third node. Even though the third node is listening on 30007, we won't be able to ever reach that specific node. If I recreate a cluster now, so Kind get cluster, delete. I'm going to delete my original cluster. This will delete everything, stop everything. I will create a new cluster, Kind create cluster with the configuration kind.yaml. This file now does have those extra port mappings. If I run this and wait for it to start all the 3 containers, waiting for a few more seconds. Let me look at Q&A if there's a good question. Does node port expose that service? Yes, it exports it on all nodes, including the master node everywhere. Doesn't matter where you visit it from, the request will reach the final place. If I do a Docker PS, now it tells me the first container pay, this port mapping has been added. So as long as there is something running on the container on this port, our machine can go to it on 3000. And similarly, if I go to my machine colon 30,008, it will go to the specific worker node slash 30,007. Now this is a fresh container that I have. So I need to apply my deployment dash class.yaml, and I need to apply service dash class.yaml. If I do kubectl get pods, it's still containing the creating the two replicas. If I do kubectl get service, this is created, but we need to wait for the containers to run. Only then will it work. Once the containers do run, kubectl get pods dash watch. They are running. If I go to localhost colon 30,007, it shows me welcome to Nginx. If I go to localhost colon 30,008, it shows me welcome to Nginx. What happens when I go to localhost colon 30,008? My request goes from my machine to the 30,007 port on the worker node, from which, since we have the service running, it forwards it to these Nginx containers. So what is happening right now? I'm going to localhost colon 3008. That is going to the 30,007 port on the worker, which is forwarding my request to pod. Doesn't matter where the pod is. It could be here. It could be here. It is of course not on the master node, but even if I go to the master node, it forwards the request here. The node port is node independent. It runs on all the nodes. Doesn't matter where your pods are running. You can go to this node port. You can go to this node port. It will forward your request to the respective pod. Do we understand node ports? Like this is the first kind of service that we have introduced that lets you expose your application on specific ports, sort of 80%, 81, 79%, decent. Let me quickly run a few experiments to show you a few things. You can try this out after the class. Basically, I'm going to show you how to do the same thing on Vultr, how easy it is when you do it on Vultr, and a second type of service called the load balancer service. The problem with a node port service is it's always available on very weird ports. It needs to start from 30,000 and go to some 30,200 kind of a number. You cannot run it on port 80. And this is where a load balancer service comes into the picture. What is the type of our service right now? It was node port. What is another type of service? The load balancer service. This will not work locally. I repeat, one thing to know about Kubernetes is even though it's very cloud agnostic, and doesn't matter if you go to AWS or GCP, when you start a Kubernetes cluster, it starts a bunch of machines on that specific cloud that are all connected to each other. One is a worker node, other are the master nodes, but it lets you provision things outside the cluster as well. Specifically, load balancers are one thing. Whatever Kubernetes cluster there is fine, but the load balancer is actually a different thing that's present on your cloud provider. It's outside the cluster. Whenever you create a load balancer service, it will create this fresh load balancer for you. If you delete your Kubernetes cluster and forget to delete this will stay on. This exact thing happened with me. I deployed a Kubernetes cluster. I had 2 of them here. I went to Kubernetes and then deleted it. I said, sorry, I want to delete it. But I forgot to delete the load balancer that was present. And when you delete the cluster, it does not delete the load balancer by default. The load balancer is not part of your cluster. All your nodes are part of the cluster. All your pods are part of the cluster. All your services are part of the cluster. This load balancer service will be different for every cloud provider. If you go and do the same thing on AWS, you will see a fresh load balancer created on the AWS dashboard. If you delete this, does not mean your load balancer gets deleted. You have to either you delete the service first, which deletes the load balancer, or if you forget to do it, the load balancer will stay for. If you go to my history of payments here, I paid them $8 a month for a really long time because even though I deleted my Kubernetes cluster, I forgot to delete my load balancer. So what does that tell you? Even though Kubernetes is everything happens inside the cluster, it does provide you things to do outside the cluster as well. One such thing is creating a load balancer. Whenever you're creating a load balancer, it exists outside your cluster. What is the benefit of this? Okay, you don't ever expose your core host IPs to the end user. When you create a node port, then your user will be hitting the IP of your server. They will directly be hitting your server. They will know the IP of your master node or your worker nodes. Versus if you have a load balancer, they will know the IP just of the load balancer, which would under the hood, of course, forward the request wherever needed. So that is what the load balancer type is. Will it work for you locally when you're using kind? No. This thing only works when you're working with a cloud that does support load balancers. You can create load balancers of your own as well. You can have a separate machine that is a load balancer. But most of the times when you're doing this, you are relying on a cloud provider. KR AWS has load balancers. Vultr has a separate section on load balancers. And whenever I create a service of type load balancer, it will create a real load balancer here. It will not use one of the machines that I already have. It will create a fresh new machine outside my cluster, which is going to be my load balancer. Let's see how you can do that. Again, if you do this locally, it will not work. Why will it not work if you do this locally? Because there is no load balancer that your Mac has, right? AWS has a load balancer, Vultr has a load balancer, GCP has a load balancer. Your Mac doesn't, which is why there are ways to make it work. It will not work if you do it right out of the box. How can I make it work on Vultr? Number one, let's quickly just create a cluster here, a fresh cluster, see how do you connect to it, see how do you deploy things there, so on and so forth. So if I go to deploy here, and feel free to do this after the class, Vultr gives you $250 of credit, something like that. So you'll be fine for like a month or two. Their clusters are slightly expensive, but you will be fine for a month at the very least. Go to Kubernetes, add a cluster, give it a name, class 27, select a region, let's say Mumbai, number of nodes, let's say 2 is good enough. This is going to be my monthly rate. Every node is $45 for a month, and give this a label, call it week 25, deploy. This will take a long time to deploy. Once it does, you will see something here in your Kubernetes dashboard. As you can see, this one is currently deploying, but I already have an old one that I can just work with. So whenever this does deploy for you, you see this in the running state, you can go here and download the configuration. This configuration, if you remember from yesterday, is all your passwords that are needed to connect to the Kubernetes cluster. So whatever this file is, let me open it in Visual Studio Code. If I copy this file, whatever file that was downloaded from here, and I go to kube/config, if I delete the original config that I have, currently my Kubernetes cluster, if I run kubectl, where does it connect? It connects to my local Kubernetes cluster. If I want to change that, what file do I change? I delete the .kube/config file, and then I can add the configuration that I got from here, the configuration that I downloaded from here. And now if I run kubectl get nodes, it gives me the 2 nodes that I have running over there on Vultr. As you can see, it's very easy to move the context from this thing to another. You can also have multiple config files and make this a little more cleaner. You don't have to delete the file like I just did, but this also works. Now, if I do kubectl get nodes, it connects to my Vultr account. It says age is 3 hours because this specific cluster that you see over here, I created 3 hours ago. I just created one right now, but that one is just, still initializing. It might take some time to initialize. The other one is still running. This one has some things already running. If I do kubectl get pods, it shows me 3 Nginx pods that I have running. If I do kubectl get deployment, I have 1 deployment running that is actually orchestrating these 3 pods. If I do kubectl get services, you will see I have 1 load balancer service that is running. So if I go to, you can find this in the slides as well, but if you go to service-lb.yaml, you will see the only thing that I've changed here is type set to load balancer. I created a new file called it service.yaml, service lb.yaml. I changed the type to be load balancer. I applied this specific file. So kubectl apply -f service lb.yaml. It is unchanged. I had applied it a few minutes ago. When you do apply it, or like a few hours ago, it will create this load balancer for you. This one right here. And then, you can visit it on port 80 and, it will forward the request to your container. So what is happening right now? Okay, I have on Vultr a Kubernetes cluster which has 2 nodes, and I have provisioned a load balancer outside. These 2 nodes are running 3 pods. One is the master node that's probably running nothing, and the other is the worker node that is running all 3 of my pods. And anytime a request comes to port 80 on my load balancer, it gets forwarded to one of these 3 pods, probably in a round robin fashion. That is how I'm able to access this over the internet. There are a lot of things missing here. How do you convert it to HTTPS? How do I point this to a domain name, yada yada? But we can get there when we get there. Do we understand this? Can you try this yourself? If you look at the Kubernetes cluster right now, I have the second one that was just created. Which one of them is it? 5:30, 15. This is 5 p.m. I'm so confused. One of them is the new one. You can just, most probably I guess this one, download the configuration, replace it, apply your pods, apply your deployment, apply your service, good to go. Thing has been deployed. One extra thing you might have to do is go to load balancers and add a firewall rule over there. So one extra thing that you do have to do is, when you go to your load balancer and go to the firewall section, configuration, networking, and expose port 80, and only then will it work. Other than that, it should just work. Do we understand load balancers? And if we do, then I'll open it up for questions. I can also, if need be, just show you how to do the same thing in a fresh cluster. We have created a fresh cluster. I haven't deployed anything there. Happy to just show that, in action if need be. All right, we sort of understand it. Don't understand it. 75%, 70, very bad. All right. Let me quickly take you through everything on a fresh cluster. Okay? What did I do until now? I created a fresh Kubernetes cluster. You can do the same thing. Click on add cluster. It will start a cluster for you. And select 2 machines over there. You have a 2 node cluster running. One of these 2 I just created. What I'm not able to understand is which one of these I just created. I would assume this one I just created. Yes, this is the one. I can download the configuration here. What is this configuration? How do I connect to this Kubernetes cluster? It has my secrets that are enough for me to be able to connect to it. I can open this in Visual Studio Code. I can copy the whole thing and I can paste this in .kube/config. This has all of my Kubernetes. This is where kubectl picks up your Kubernetes credentials from, picks up where it needs to connect. There are better ways of doing it. You can have multiple contexts and you move from one context to another. But the easiest way is just remove it, replace the credentials. And now if I do kubectl get nodes, it has 2 nodes. Do I have any pods? No. This is a fresh Kubernetes cluster. Let's see the deployment-class.yaml file. What does this file say? It says, KR, I want to start a deployment with this name, with 2 replicas, with these selectors. KR, the final nodes that will be created will have these labels. That is how I will know, okay, those are my nodes, or like my pods, sorry. And this is the spec for it. I want to start the Nginx image over there. That is the first thing that we create. If I now apply deployment-class.yaml, it says deployment has been created, which will eventually create my pods. My pods are currently in the container creating state. Eventually they will get created. That is the first thing I do. What state do I have by the end of it? I have 2 machines on Vultr in my fresh Kubernetes cluster, which have 2 pods of mine running. I have 2 machines. One is a master, one is a worker. The worker node has 2 pods running. I have no external access right now. I cannot I don't have a node port running. I don't have a different type of service running. I only have pods. What did we learn? If you want to expose your applications over the internet, you need to create a service. And service can be of many types. Cluster IP, if you only want it accessible internally, this pod wants to hit one of these pods, you can create a cluster IP service. Or you can create a node port service. I'm going to expose a node on both of my machines that the users can hit. Or a load balancer service. Let's start by creating a simple node port service. I have two nodes. I'm going to expose a port on both of them, which will forward the request to my pods. What would the file look like over there? If I open service-class.yaml, this is what the file would look like. Okay. I want to create a service which selects the pod to forward the selects to based on these labels. And this is the target port on those pods. This is the node port where the end user will send a request. If I apply this, it says service has been created. If I do kubectl get service, it says this is a node port that is exposing something on port 30007. Now if I go to my nodes, if I go to compute over here, the two nodes that have been created for me, which most probably are going to be this one and this one. If I change the firewall rules on this, settings, firewall, update firewall group, I already have one where this port is open, or I can create my own as well. Manage. I already created one for the old nodes that I'm just reusing here. If you did not, you will see an option like this to add firewall rules. Here I want to open port 30007 on my machine. Same for IPv6. If you want to, IPv4 is fine. If I now go to the port IP, let me just show this one more time. I think I went a little too fast. If you open any of your nodes, let's say this one right here, you go to settings, you go to firewall, you should see an option to create a new firewall rule. For me, I had to update one. I'm sure there's a way to create a new firewall rule as well. Add firewall group, call it whatever, week 25, and open up port 3007 here. Add a rule to open the TCP port 30007 from anywhere. That should be saved. And now I'm going to apply this week 25 firewall group over to any of my instances. Bear with me for 5 minutes. I'll probably do a recap after this, or just open chat after this. And I can over here go to firewall rules and say, KR, you are going to have week 25 firewall group. Now I've opened port 30007 on my machine, and I've also added a node port service. If I go to kubectl get service, it shows me I have a node port service running on 30007. If I go to my machine's IP, :30007, I see the welcome to Nginx page. This is using what? This is using the node port service, the first type of service. The problem with which is, okay, you have to expose the IP of your machine. This is the IP of my week 25 machine over the internet to the world. How can you fix this? You can say, yeah, my service is not of type node port, but of type load balancer, and apply this again. Now what will happen is a fresh load balancer will be created on your Vultr dashboard. If I go here to load balancers, you will see a new one is being created, and whenever this is created, I can just hit the load balancer, which will forward my requests. Rather than having a service of type node port, I created a service of type load balancer, which provisions a load balancer outside my cluster. It provisions a load balancer. This is my cluster, provisions a load balancer outside it. I can just hit the load balancer. We'll take a pause here, and happy to take questions now. Boy, end mein thoda zyada tez ho gaya nahi? Let's do a quick poll and then we'll do questions. I'm sure there are some standard questions that can help answer a few doubts. But how was the class? Fast, slow, good, bad? Oh, decent. Not great. 76%. Okay, I'm going to open chat. Lot of questions. Let them flow. All right. Whoopsie daisy. I was wondering if you can use etcd just like Redis, or are they different? You can use it like Redis. If you want a distributed key value store, you can use etcd. They are not different. Redis gives you a lot of other things. etcd, I think, is only a key value store. But I missed your announcement yesterday regarding $50 bounty, so I'm not sure if I got it. You got it. We will add this to the cohort, and like in the notes somewhere. Yeah, you got it. If I run a deployment with replicas equal to 5, then all 5 pods are starting on a single node, or else get started in all nodes. They get distributed across various nodes. If you remember little bit about the architecture of Kubernetes yesterday, I said the master node has something called the kube scheduler. The master node has the API server, the thing that you interact with when you run a kubectl command, and a scheduler. Whenever a pod goes into the pending state, यार 5 pod चलाने, whenever 5 pods are in the pending state in etcd, kube scheduler will figure out कि अच्छा, what is the best node for me to put them, and then assign that specific node to that specific pod. So you can have the 5 replicas will run on various machines. They will not go on a single node. Can we build load balancers in-house? What are the companies that build it or get it from outside? If you have your own data center, then yes, you will have to build a load balancer yourself. If you want to have a load balancer service, you can just have a single instance running Nginx. You can also use something called ingresses that we'll be discussing tomorrow. That will make your life much easier. But yeah, if you want to use a load balancer only and you're not using a cloud provider, there is another 5th service here along with, the Kube Controller Manager. There's a Cloud Kube Controller Manager or Kube Cloud Controller Manager that you'll have to hook into. That is what calls the API on AWS. Here you need to start a load balancer. So you'll have to hook into that API and, create your own load balancer, which is probably what you're asking. When I deployed the application on EC2 instance with auto-scaling container min to max 10, so all container is on EC2 instances or one container on EC2. When you deploy an application on an EC2 instance with auto-scaling container, what do you mean auto-scaling container? Do you mean an auto-scaling group with minimum 10, minimum to maximum 10? And if you mean auto-scaling group, then you have just one container running on an EC2 machine, and you have 10 such EC2 machines running one container. I'm unsure if your question is about auto-scaling groups or not, but if it is about auto-scaling groups, then, if you have minimum of 2 and maximum of 10, you have 10 machines. Now it depends on you. When a machine starts, do you run just Docker run backend, or do you run Docker run backend and Docker run frontend? If you run both of them, then you have 2 containers running. If you run just one, then you have 1 container running. This is for auto scaling groups in AWS. This is not for Kubernetes. I'm assuming your question was about that. Also, guys, class is done. If you have more questions, feel free to stick around. Else, feel free to drop off as well. Who maps the load balancer? What do you mean maps the load balancer? I'm assuming you mean how does the load balancer know where to send the request? And the answer is if you look at service.yaml, we say anything that has app set to Nginx is what you need to forward the request to. If I do kubectl get pods, it shows me 2 pods. If I describe one of these pods, kubectl describe pod, it shows me that this pod has app equal to Nginx as one of the labels. And what does my service.yaml say? Anyone who has app Nginx, forward the request. So that is how the load balancer is able to understand where to forward the request. When I deployed the app, okay, answer that. What are few situations when Kubernetes can get messy? Operation wise, if you have lack of expertise, it can get messy. If you have some internal Kubernetes bug in your cluster, if you're self-hosting, it can get messy. If you have people who don't understand what are deployments, things like these, it can get messy. When you hook this into the CI/CD pipeline, we will eventually. That's actually not too messy. It's never messy. It's just lack of expertise in the team that leads to a lot of complications. So unless you have people who know Kubernetes well, you shouldn't move to Kubernetes. A single EC2 machine, very big beefy machine, is fine for a long time. Unless you're a very big company, now have reached millions of users who are sending you requests, doesn't make sense to move to Kubernetes. Or you're a very cloud native company, though you want to, or you have very big expert in the team who's. Kubernetes can give you cost savings as well. Your cluster has all of your things in a single place, so they can share load amongst each other, things like these. So yeah, it will add a lot of complexity unless you have someone who's really good at Kubernetes or decently good at Kubernetes in the team. Do not move to it. If you have, then there are no downsides to moving to Kubernetes. Operation wise, if anything, it's much better than the other solutions, because it is highly self-healing. It has rolling updates. So if things go down and you're sleeping, next day you'll see, my deployment hasn't happened, but at least my systems are still up. It is still running the old commit from yesterday or old release from yesterday. So operationally, it's actually makes your life much easier. What kind of machine sizes should the master and worker nodes have? Depends on your load. If you think your load is finally going to be a lot, or you're going to have a lot of people visiting your application, then choose big machines. The answer remains the same based on how would you choose. Let me just delete everything here so that I think I exposed my secrets. So let me just delete these. What I was saying was, the answer remains the same. How would you choose an image size if you are deploying it outside Kubernetes? Based on your load. If you have a million users that are hitting, you'll probably use a C5x large machine, or a C5 5x large machine, a machine with 128 vCPUs or 64 GB RAM. But if not a lot of people are visiting, then you'll use a micro machine. So similarly, your cluster also. Initially, you can start with a small one. Whenever you think there's a lot of load, all you have to do is increase the number of nodes, and you're good to go. How does the traffic get distributed when exposing ports? Is it sent to one pod? No, it is evenly distributed. Most probably in round robin. Read about it. How does the service work? Does it under the hood? I would assume it just does a lot of round robin. Do pods? I could be wrong on this. Might just do it on the basis of load, but I think it does round robin. Round robin means first send to the first one, then to the second one, then to the third one. Does the pods each have particular CPU memory limits, or are they flexible? They are flexible, but you can introduce limits. We'll be coming to this soon. I discussed this a little bit when I was discussing Replit yesterday. You can put limits, both minimum and maximum limits. This pod should not take more than 2 GB RAM, or more than 3 vCPUs or 2 vCPUs. So you can put those limits. By default, you can have one pod that just hogs everything. Next week will also be Kubernetes only. I'll probably release a bunch of offline videos. Next week will be Kubernetes. We'll try to finish it by next week so we can move on to projects. We have a few other things to cover, I think. Docker Swarm, someone mentioned, probably be an offline video. I'll have to look through the syllabus. But this was the biggest thing that's left. Everything else is simpler to understand. If you understand this, everything else should be breeze. Are Kubernetes nodes Docker containers? If not, then how come they are using Docker commands to get info about these nodes? The containers which start inside pods, are they Docker containers? Great question. Kubernetes nodes are not running on Docker. When you use kind locally, when you use KIND, the name itself says Kubernetes inside Docker. When you're doing it locally for testing purposes, yes, you are running it using Docker. But when you start a bunch of Kubernetes clusters here, which start a bunch of machines over here, those machines are not running Kubernetes inside Docker. They're natively running Kubernetes. As you can see, I deleted my Kubernetes cluster. My load balancers are still up. Last time I did this, I forgot about this. I paid them for months and then realized, I have been paying them because my load balancers are still up. So make sure you delete them separately, or you delete your service, which would automatically delete the load balancer. What was the question? It was a good question. Yeah. But all the commands that we're running, these are not Docker commands. When I do kubectl get pods, of course it will not run now because my server is down. I just deleted the cluster, but kubectl get pods. These are not Docker commands. These are Kubernetes commands. the place where this HTTP request goes is the Kubernetes API server, not the Docker daemon. So all the commands that we're running here are Kubernetes commands. Yes, the final container that is running on Docker, but that doesn't, or more specifically running on the Docker runtime, but that this container runtime can run any type of container, not just Dockers. You can have, there are like various other container runtimes that exist. Kubernetes has this concept of, what is it called? I totally forgot. CRI, container runtime interface. I think it is called that only. Where is that person who said I have 3 years of experience on Kubernetes? It's called a CRI, right? Or something else. It basically has something that lets you, no. Basically, that has something that lets you very easily run any type of containers. Docker is just one type of container you're running. You can run, other types of containers as well. Container is a more generic concept. Docker containers are just the commonly used containers, and Kubernetes supports every type of container. Amazon has EKS similar to Vultr. Yes, Amazon has EKS. Google Cloud has GKE, Google Kubernetes Engine. Every cloud provider supports Kubernetes today. Just a small doubt. Every pod can have more than one containers, right? Yes. So if there are two backend and they are in the same pod but different container, how can we reach both the backends? You can have different services, right? So you can have one service that points to the port 80 on the machine, other service that points to the port 81 on the machine. That way, whatever your machine IP colon 30,007 points to the first backend, and then your machine IP colon 30,008 points to the second backend. This is an array, right? Ports is an array, so you can add multiple ports that are exposed over a service on a specific container. So yeah, you can add just another entry here. Yeah, the target port for the second process is 81 and the node port is 30,008, let's say. All right, open chat. CNI. CNI, CRI, I don't know, one of these two. I think it's CRI. CNI is something else, I think. Could be wrong. When to use Kubernetes versus EKS versus ECS? Kubernetes and EKS are the exact same thing. EKS stands for Elastic Kubernetes Service. ECS is something else. When to use which depends on if do you want to be extremely cloud native. Do you want to make sure that you can easily switch out of AWS? Then you have to use Kubernetes. You cannot use ECS. ECS is restricted inside the AWS ecosystem. But if you're okay with it, if you understand ECS a little bit better, you need elastic compute service, which means you just give it a bunch of containers, it starts it. Then you can use ECS. So it depends on you basically. What would I do is the question. I would probably go with Kubernetes. If you have decent expertise in Kubernetes, you go with Kubernetes, period, full stop. But ECS is easier to understand. Auto scaling groups are even easier to understand. Elastic Beanstalk is the easiest to understand. So a lot of times you don't have time to, you just go with whatever you understand. But if you understand Kubernetes, you use Kubernetes. Difference between port and target port. Port represents how can internal services find this specific pod. Target port represents what is the final port where this is running. So this port represents, I think it could be wrong, but this port most probably represents how do internal services find this specific service. If you have one pod, I will confirm this after the class, most probably that's what this is. If I have one pod, two nodes over here, this node has one pod, this node has different pod. If this pod wants to visit this pod, it can do it on port 80. But if someone wants to access it via a node port, then they do it on port 3007. And then the target port, as the name suggests, is the place where it is running over here. We were running Nginx. Nginx runs on port 80. But if we were running a Node.js application that's running on port 3000, then we would run port 3000 here. The port that you see over here, most probably, I could be wrong, you should check, most probably means how does internal pods access this specific service. All right. Okay. When in Kubernetes, I have front-end, back-end database on different containers and in one pod. You shouldn't do that. But let me read through your question. Where can I define that if the pod has 3 containers, I define volumes associated with the pods? Yes. So if you have a front-end, back-end DB application, You will have front end on a different pod. You will have back end on a different pod. You will have your database on a different pod. Your database pod will have something called as a persistent volume. We will discuss this most probably next week. If you want to do databases inside Kubernetes, which horrible idea, can do it. Most companies don't do it. I would say 95% of the companies do not use Kubernetes to deploy their databases or anything that has state. If you do want to do it, then Kubernetes does give you this concept of persistent volumes, which, as the name suggests, lets you persist data across pod refreshes. A pod can die and then come back up, right? A pod is ephemeral. Ephemeral is a new term if you want to learn. Ephemeral, which means, it goes away very quickly. Pod can start, as you saw, I deleted it, it got restarted. So if you want persistent volume, if you want to create a database inside a cluster, you will have to use something called as a persistent volume, which, as the name suggests, lets you persist data across pods restarting. What is the second question? When can I define which pod will run on which machine? I don't know if you can define that. Can you? Can we define which pod runs on which node? How can I get the node which a pod is running? Assigning pods to nodes. You can constrain a pod so that it is restricted to run on a particular node or prefer to run it on particular nodes. There are several ways to do it. Yada, yada. Recommended approach to use label selectors to facilitate the selection. Often you do not need to set any of such constraints. The scheduler will automatically do a reasonable placement. So yes, most of the times the scheduler, what is the scheduler? Will do a reasonable placement, KR, amongst all the machines. This one has the least CPU right now. Let me put it here. But if you want to do it, seems like you can attach some sort of a label when you're starting the pod and define which node selector items match expressions which is in this specific zone. So if you add node affinity, which, as the name suggests, what does affinity mean? Affinity means I have attraction towards someone. So in your pod spec, you can add node affinity. If the zone in which the node is running is one of these two, I am more aligned to run on those nodes compared to the other ones. That's what I would assume this means. So yeah, you can do it if you want to really restrict a specific pod to run on a specific node. All right, let's see. How replica set is auto scaled when nodes are set to auto scaled. Different things. Nodes auto scaling is a different thing. If this is your Kubernetes cluster, if there is a lot of usage happening, the number of nodes will go up. Replica set scaling, or replica sets don't auto scale. Replica set there is a different way to auto scale called as HPAs, horizontal pod autoscaler, I think. But when you're creating a replica set, then you're giving it a number. The number of replicas I want is 5. It is not auto scaling. It is scaling up or down based on this number. If you make this number 1, then the number of pods go down to 1. If you make it 5, they go up by 5. This you are doing manually. When you are doing auto scaling nodes in, let's say, Vultr or AWS, is when they have their own rules of the CPU usage is above a certain level, or if every pod of yours you have put restrictions, it needs to have 1 GB RAM, and you have and you have 100 pods running, all of your nodes don't have enough capacity to handle another pod, is when it will auto scale. Naya pod jo aaya needs to go to the new machine. If this machine also fills up, if this is a 2 GB machine and you start 3 pods here or 4 pods here, then it will understand I need to auto scale up even further. So node auto scaling happens based on your cloud provider. Replica scaling up or down happens based on the number of replicas you give it. All right, let's see. Could you explain cluster IP? Cluster IP says, I deleted everything. If you have 2 nodes, let's say 3 nodes, and you have Nginx pod running in 2 places, let's say, and then you have a third service called, let's say, the backend, and you want this backend to talk to Nginx, send an HTTP request to this Nginx container. How can it do it? Either it will have to find the IP of this specific Nginx container. How do you do that? You can do kubectl get pods -ovide. It will give you the IP of that specific pod. My container is down, my cluster is down, which is why you see this, but you get the idea. You get the IP of that pod, you can hit that pod. But if I create a cluster IP service, what does the name say? Okay, I need an IP for my Kubernetes cluster. I don't want this IP to be exposed to the world. Just how this has an IP and this has an IP. Give me an internal IP where if the another process sends a request, I will load balance it across the two pods that I have based on my selector. Based on my, every service has what? It has a selector. Okay, I am going to forward request to any pod that has app set to Nginx, which is this one and this one. If you create a cluster IP, it means any request that's coming from somewhere else inside the cluster, it will get load balanced so that you don't need to know, acha, this ki IP kya hai, this ki IP kya hai, load balance them yourself. You get the cluster IP, you send a request that it load balances it. So it's for internal cluster IP, right? It's an IP for inside the cluster. Okay, let's open it one more time. I think a lot of questions went up. So more questions, guys. All right, we'll start from the top this time. I'm second year experience with someone like CTC. Give me referral, please. Okay. What is cluster IP? Why is a cluster IP service automatically created every time we create a node port service? My guess is it is created initially when we create the Kubernetes cluster for the nodes to talk to each other. Why is a cluster IP service automatically created every time a node port service is created? Let's see if that happens first. I don't think that is true. I could be wrong. Kind get cluster kind get clusters kind delete cluster dash name local 2 kind create cluster why let me answer the other questions. Why is cluster IP service? Okay, answer that. I need to answer that. You mentioned that Kubernetes is always better if you have expertise in it. That is not the best statement, but so I did say that. But can you combine Kubernetes cluster with an auto scaling group? Okay. Won't that solution be cloud agnostic? I think you mean cloud specific. But can you combine Kubernetes cluster with auto scaling group? Just how Walter had it. Yes. Won't that solution be not be cloud agnostic? Exactly. Yes. If you have auto scaling, if you have load balancers also, there are a lot of things that happen on the cloud level. It is still cloud agnostic. You can still move from Walter to AWS. Wahan pe you can add a node group. Okay, minimum is this much, maximum is this much. It makes it very easy for you to move from one cloud to another. Now, if you want to move on your own cloud, then you have to implement all of these auto scaling policies, load balancers, things like these. But it is still cloud agnostic because you can, DigitalOcean gives you a minimum maximum that you can auto scale to. So does AWS, so does Walter. So you can still move from one cloud to another. Can we make the control plane node be smaller than the worker nodes? Yeah, you can. I mean, if you want to start it yourself, you don't necessarily have to use their Kubernetes offering and start. You can start 3 EC2 instances. You can start, one of them is small, 2 of them are bigger. You can start Kubernetes over there, and you can select the smaller one for the worker node. I would assume. Okay, that is not a problem. Which will be the actual deployment? So I don't know. I think you can do that. I can't think of any reason why you wouldn't be able to do that. I want to deploy an LLM internally and want to know, should I deploy by EC2 or use ECS? LLM internally, you should use ECS. You probably want, anytime a new conversation is happening, you create a fresh container for the user and the user talks to it through the duration of their chat. And then, whenever the chat ends, you close it down. If you have a single EC2 machine, for example, if 100 people start talking, your machine will blow up. You need some sort of auto scaling. Here, you actually need stateful auto scaling. I repeat, you need stateful auto scaling. Whenever some user came to your website, this is the browser of the user, and they started a conversation with you. you need to make sure that this conversation goes to the same container slash machine, right? Because this machine, I'm assuming, has some context of that conversation. Unless every time the user sends a message, you send them the whole history along with the new message that the user sent. In that case, it doesn't matter. These can be stateless. But if that is not the case, you are maintaining some history of the user on the server in memory, then you need to make sure your containers that you have here or machines that you have here, browser 1 is connected to container 1 throughout their history of the chat. Browser 2 is connected to container 2 throughout the history of the chat, so on and so forth. So if that is the case, you definitely need ECS or some auto scaling construct that lets the user connect to a machine and that machine stays up for them through the duration of the chat. If that's not the case, then you can use whatever you want and scale up, scale down based on CPU usage if it's not stateful. Is Shami Secret a good example of using a Kubernetes for multi-cloud deployments? How is it done in Web3? That is exactly how it is done in Web3. That is exactly how it is, not Shami Secrets. MagPie had like a MPC cluster, which is very similar. But yes, you had multiple AWS accounts. Each AWS account had its own Kubernetes cluster. And you would deploy secrets on different Kubernetes clusters, and you would make sure one developer only has access to one Kubernetes cluster, another developer has access to another Kubernetes cluster, so that even if the developers want to screw you over, you need all developers. The team needs to get together, only then can they, basically reducing the number of points of failures. Okay, even if 2 developers think like we will steal the private key, there are 5 servers and you need all 5 private keys, so on and so forth. So yes, that's Kubernetes. Multi-cloud Kubernetes deployments ka best use. One of the best use cases is MPCs, or in your case, Shami Secrets. All right, where was this question? It was a good question. How to deploy a Next.js app using Kubernetes? If yes, how do you scale it? Similar to CDNs, what is the best way to deploy a Next.js application? Unfortunately, a Next.js application, there are some parts of it that you can CDNify if your application has static site generation. There are some parts of it that you can serve over a CDN, which is the ideal cheap way to serve front ends. React, the best thing about React is you can serve everything over a CDN. You don't have to worry about server side rendering. That's not the case in Next. So serving a Next.js application is very similar to serving an Express application. Okay, you have a server that needs to do some work and then return some things to the end user. So EC2 is the easiest way to do it. Auto scaling group on top is even better. If you want, my application is deployed everywhere all around the world in small machines, then you can use Cloudflare workers. You can use Vercel. That's exactly what Vercel provides you. They deploy your Next.js application in various places all around the world, and then if a user hits them, they go to their closest edge server. So the dumbest way is you deploy your EC2 machine one place and just deploy it over there. That's cheap. If you use something like AWS, if you want edge servers all around the world, then it will get expensive. That is why Vercel bills are so high, because they can charge you whatever they want. They help you deploy on various machines all around the world. Can you create a Kubernetes cluster? Sure, you can. Do you need to? Probably not for a Next.js application. You can have a simple set of machines all around the world. Just geographically distribute your application well. Have simple EC2 machines in 10 different places, and then serve it over a load balancer. Easy enough. Yeah. Can you do something better for Next.js specifically? There might be some things that Next.js does that I'm missing here. Not Next.js. Vercel does, that might be their Cell. If you deploy on Vercel, we give you XYZ. So figure out what that XYZ is. Edge servers is one such thing that they give you. You'll be very close to your users' server will be very close to them. Things like these. You cannot CDNify a Next.js application, unfortunately, because every user gets their own response. As I said, it's similar to an Express application, so you cannot put a CDN in front of it. There's no caching that you can do. Every request returns a different response in most cases. Of course, the landing page will look the same for everyone, but when you go to the courses page, it will look different for everyone. So you can't have any sort of caching. CDNs sort of don't work. You need edge servers, which means there will be some compute running on every machine. And yeah, so if you really want to build the best Next.js deployment, then have multiple servers all around the world. Else, simple EC2 machine, or maybe like 5 EC2 machines, one in Asia, one in US, one in India, one in Sydney, one in Europe, and connect them via load balancer. All right. You mentioned Kubernetes is always better. Okay, answer that. All right. Let's see if my cluster is created. Kubectl get pods. Apply deployment.yaml kube. Get services. Do you mean this cluster IP? This is one default cluster IP for whatever. I would assume to talk to the API server. I could be wrong. But other than that, if I apply any service, for example, service.yaml, what do you mean another one is created? There's just a single node port service that was created, right? There isn't another cluster IP service that was created. What's the question again? In a cluster, where was it? Where was that question? In a cluster, what decides the master node count to be 1 and other as workers? Sorry, it's a different question. In cluster settings, we can set min count 1 and will be same node master and worker. Yes, you can have, if you have 0, if you have one Kubernetes cluster, yes, that cluster will act as both as a worker and as a master. You shouldn't do it. You should have a minimum count of 2 always. But yes, if you do it, if you run kind locally without any configuration, it starts a single server. It's fine. Can be master and sleep, whatever, master and worker. You shouldn't do it because your master should be an independent server that is serving other requests, handling a bunch of things, user requests, all the things that a master does. So you shouldn't really use it to deploy your application as well. But can you? Yes. All right. I lost the question again. Any more questions, or that specific question that was there, or can we call it here, guys? Any more questions? Where is the config file present? Okay. You mean this one? Cat kind.yaml. I don't think this is present anywhere. Let me quickly add it to the slides. Should be in services. Very good. It's right here. Restart the cluster with a few extra ports exposed. It's whatever the slide is, 19 or 18, something like that. The slide that's titled services, you'll find it here. All right. Where is the all right, I will check the Discord DMs soon, Javed. Tomorrow, I'll do a YouTube live, so we can do it there. Kubernetes part 1, I think we did this yesterday. Let's see part 2. Add a cluster, Kubernetes. The Lambda service exposes the service externally to a cloud provider, right? This means that the service is accessible from outside the cluster using the load balancer IP. That is correct. This is a better way to expose to the outside world. That is correct. But we can't use load balancer. Service with kind. That is correct, because you're running it locally. You don't have any load balancer implementation locally. So we will use Vultr to create a cluster exposure over the load balancer, create a new account, replace this thing. Perfect. Love it. Very, very cool. Yeah, we should talk, man. Get in touch with Akash. Let's see if we can plug these in somewhere. These are pretty detailed notes, Oh, okay. So these are just packages, but works. All right, cool, guys. Let's call it here. Thank you, everyone, for joining. I will see you guys next week and in some offline videos, maybe on YouTube as well. Yeah, bye-bye. Web3 alphas, none yet, but, happy to discuss the next one. All right. Bye-bye, guys.